Today we're going to talk about the average rate of change. So the average rate of change of a function over an interval is essentially the slope. So even if the line is not straight, because straight lines have a constant rate of change, we could just find the average rate of change along any other line, a curve, anything like that, just by focusing on the interval, right? The interval being how far, a specific pair of x values on the graph. That's what we're going to define as our interval. So we're going to find it the same way we would have found slope of a straight line, right? Change in y over change in x, y2 minus y1 over x2 minus x1. And the way we could also think of it now is the y values are, we're writing them as functions. So f of b minus f of a are the y, and then the b and the a are the x and the x. And they're using a and b to represent the two numbers in our interval. So for example 1, calculate the average rate of change over the specified interval. So this says from 1 to 4. So x is 1 here. So 1, -1 is a point we're going to use. And x is 4 here. So we're going to find out what the slope is of the line between these 2 points only. It would change depending on what pair of points we chose. So it's change in y over change in x. So 14 minus -1. Right, subtract the y's, 4 minus 1, subtract the x's. So 14 minus -1 is like 14 plus 1, so 15 over 4 minus 1 is 3, and 15 over 3 is 5. This next one's showing us the interval and interval notation. So they're saying x is 1 to x is 5, and we're actually going to have to plug it in. So if I have x is 1, right? Evaluate when x is 1. That's going to be negative times 1 squared plus 4 times 1 minus 1. So 1 squared is 1 times negative is -1 plus 4 minus 1. So 4 minus 2 is 2. So we have the point 1 comma 2 so far. We're also going to have to plug in 5. So g of 5. So negative times 5 squared plus 4 times 5 minus 1. So 5 squared is 25, so this is -25. 4 times 5 is +20, plus 1. So this is a -5 minus another 1, -6. So we have the point 5, -6. So doing our slope, -6 minus 2, 5 minus 1, which is -8 over +4, which turns into -2. So one thing to note here is when we look at our average rate of changes, the sign tells us if it was rising or falling, right? Increasing or decreasing. And then the number itself is how quickly that is happening. So an average rate of change of +5 is greater than an average rate of change of -2, but a -5 would also be a greater average rate of change than -2. Okay, so even though -5 is a smaller number than -2, the 5 itself is bigger than the 2. So we're just going to keep that in mind for later on. So here's one for you to try. All right, really 3 for you to try. We have a table, we have a graph, right? So from -7 is x to -3 is x. So you could figure out those points. And then the equation like we did as well. So you can pause, the answers posted in the blank notes in Google Classroom. All right, so example 2, we're going to consider the graph of this quadratic function shown on the graph. We want to find and compare the average rate of change on the two intervals, 1, 3 and 3, 5. And then what does the average rate of change tell us about the function on those two intervals? Are they increasing, decreasing? How quickly? Things like that. So first, I'm going to identify where x is 1, it's 0. And when x is 3, it's -4. So first, I need to find my slope between those 2 points. So that's going to be negative 4 minus 0, right? Y minus y, 3 minus 1. Negative 4 over 2 is negative 2. So from 1 to 3, my average rate of change was negative 2. So now I'm going to go from 3 to 5. So we already know it was the 0.3, negative 4. And at 5, that's 5, 0. So that's going to be 0 minus negative 4, right? Or 0 plus 4, 5 minus 3. So positive 4 over positive 2 is a positive 2. So on the interval 3, 5, my average rate of change was positive 2. So what this tells us is that the two intervals have the same rate of change, but it's decreasing from x is 1 to x is 3 and increasing from x is 3 to x is 5, right? They're both a 2, but this was going down because it was negative, and this is going up because it's positive. So that is what we will say. The two intervals, it's going to be long, have the same rate of change, but decreases from x equals 1 to x equals 3, and increases from x equals 3 to x equals 5. All right, example 3. A rocket is launched from a cliff. The relationship between the height of the rocket h in feet and the time since its launch t in seconds is represented by the table below. So we're going to calculate 3 different rates of change. The first one between 0 and 2.5. So 0 and 2.5. So that would be 484 minus 384. And that would be 2.5 minus 0. So that's 100 over 2.5, which is really equal to 4. So then we'll go between 2.5 and 5. So that's 384 minus 484. And that's 5 minus 2.5. So now that's a negative 100 over 2.5. So that's actually equal to negative 40. And then between 5.5 and 8, that's going to be 0 minus 340. And 8 minus 5.5. So that's going to be negative 340 over 2.5. So this actually equals negative 136. So on which of the given intervals does the rocket have the greatest rate of change? So ignoring the signs, the 136 was the biggest number. So that would be between, oops, that's not how you spell between. T equals 5.5 and T equals 8. So what does the negative average rate of change mean in the given context? It means it's falling back to the ground, right? We're talking about a rocket being launched from a cliff. When it's a positive rate of change, it was rising still. And once it started going back down, that's when the change turned negative. So that would be the rocket is falling back to the ground. All right, one more problem. So given the two functions n of x and g of x, so n of x is given to us as a table, g of x is given to us as a function, which statements about these functions is/are true? So it's possible more than one is true. So over the interval negative 1, 1, the average rate of change for n of x is less than that for g of x. So we need to find n of x, and we're going to see if it's less than g of x. So n of x between negative 1 and 1 would be 9 minus 5 over 1 minus negative 1. 4 over 2 is 2. For g of x, we have to plug in both negative 1 and positive 1. That's negative times negative 1 squared minus times negative 1 plus 6. So positive 1 times negative is negative. That's positive. 6 is 6. Plugging in positive 1. We have a negative 1 minus 1 plus 6. That's 4. So we have the point negative 1, 6, and positive 1, 4. So that's going to be 4 minus 6 over 1 minus negative 1. We get negative 1. So they're saying the average rate of change for n of x, which was 2, is less than the average rate of g of x, which was negative 1. So 2 is not less than negative 1, so this is out. This is not true. The y-intercept of g of x is less than the y-intercept for n of x. So the y-intercept for g of x would be when x is 0. So x squared's gone and x is gone. We're left with 6. So for g of x, that was 0, 6. For n of x, again, it's when x is 0. X was 0 here. So that was 0, 8. So they're saying the y-intercept of g of x, 0, 6, is less than the y-intercept for n of x, 0, 8. That's true. Right? 6 is less than 8. For our last one, the function g of x has a greater maximum value than n of x. So the maximum value, and I'm now realizing I'm not sure. Yeah, we talked about this. This is fine. So for n of x, the maximum value would be 9. Right? The y value is 9. It's the highest y value we see. The function g of x, we would need the vertex for that. So I'm going to find the vertex of this equation, right? Negative b over 2a. So that's negative 1 over 2 times negative 1. Positive 1 over negative 2 is negative 1/2. Okay, make sure we did that right. Okay, so now I'm going to put negative 0.5 back in. Sorry, yep, that's right. So this is going to be positive 0.25 times negative is negative 0.25. Negative negative is plus 0.5 plus 6. Whoops. So this is going to be a positive 0.25 plus 6 is 6.25. So g of x, which had a max value of 6.25, has a greater value than n of x, which had 9. So 6.25 is not greater than 9, so that is not true. And that's the end of the average rate of change.